This battery is a deep cycle battery for RVs and is in good condition. The problem that I have here on this next project is that it has come to my attention that these tiny little wires, such as this one and this one, which are the ones that connect to the trailer, are utterly inadequate for the amount of amperage that is needed for the trailer's battery needs. This is part of the electrical system that I'm trying to rewire from the battery. As you can see, there's a meter there that shows battery voltage, but it doesn't show the amperage being used. That socket on the extreme right here, unfortunately, will only run very low amperage items, and I am unable to run an electric fan or a air pump or anything from that socket. There's another socket like it on the other end of this cupboard down there. This switch, of course, is what turns on the meter. With dishes now removed from the cupboard, I'm able to show you my electrical panel back there, which is hidden behind nothing more but a piece of cardboard box to keep it insulated away from the dishes or anything else that might come in contact with it. This is the destination for the wires coming from the battery. I will not be bringing the jumper cable wires all the way up the wall here. That would be quite unsightly and unnecessary. But I will be running 8-gauge wire, the equal size to it, up this side over here to come back into this electrical panel to hook up all my DC circuits in this trailer. As you can see, I've already removed these clips from off the wire. I've taken a little bit of insulation off these wires, but not far enough back. I need enough distance to come through this. So it's almost far enough, but I also noticed that I need to double the thickness of this. So I'm going to cut back enough insulation and fold it over to clamp in this clamp. As I have said, this wire diameter is not quite big enough to have a good proper fit on this cable. Now, experience has taught me that moisture can get inside of all the cracks and grooves and that, causing corrosion, which of course causes the efficiency of the cables to drop. So to prevent that, I'm going to be caulking around those areas with this to seal it off from any water getting into it. They may not look pretty, but they do function quite well that way. I've yet to ever have a set of cables corrode inside from moisture. Okay, testing for continuity to make sure I didn't cross my wires. I have this connected up so that whichever one of these is red, it's red. If that'll be red. If it's black, that'll be black. This one shows continuity. The one I have there is red. And it is not the black one. That's what I needed to know. I found that the wires on this didn't want to hold onto the clip that I was trying to fasten onto it. So I'm going to have to solder the wires together and onto the clip that goes onto the post. With this liquid electrical tape, I have been coating the wires here around layer after layer to build it up until it will have a good insulation on it. The wiring is done, and as you can see, the wiring is done here too. Okay, the wires come through the wall up there and made their way down here. I made a loop out and around so that in the future, if I needed a little extra slack, I've got it. And then I brought the wires down and over to these terminals. I have connected everything up in the wiring and tested out the circuit. Everything is working a-okay. In the past, a fan like this I couldn't run in this trailer because the amperage wasn't good enough. So to test if it's actually going to work, it works. Eureka! Now we can cool ourselves off during the hot weather.